Ladies and gentlemen, could you please join me in welcoming Mr. Curtis Rodgers, Principal of Brick Mortar Ventures and the founder of the Society for Construction Solutions.
Thank you. Thank you to the Ananda team for the exceptional reception. I arrived on a plane just a few hours ago, but they had everything taken care of. Got even a chance to go take a shower, and I'm feeling good, very happy to be here with all of you today. So, as was mentioned, my name is Curtis Rodgers. I'm a principal at Brick Mortar Ventures, and I'm the founder for the Society for Construction Solutions. And of course, we'll be talking about construction technology investments and trends. So, Brick Mortar Ventures was founded in 2015 by Darren Bechtel. And if you may be familiar with Bechtel Construction, Bechtel is the largest construction firm in the United States, and Darren Bechtel is the brother of the CEO, so he is like fifth generation construction family, and Brick Mortar Ventures is the organization he founded to kind of make his mark in the construction space. So Darren hired me over 4 years ago, and we teamed up and we raised about $100 million from corporations in the space, and we are investors in construction technology. My other teammates, Kostub Pandya, he was the co-lead for McKinsey Construction Consulting. So if you've read any of the McKinsey reports about the future of construction, Kostub was one of the authors. And then Austin Yunt, my other business partner, fantastic guy, Stanford economics, former professional baseball player, but he was also a startup operations expert. So he helped a company called Enjoy scale to like 500 employees, very successful. And then Alice Lung, she worked at another construction firm, and she actually set up a construction company in Singapore for over 2 years. So we have a very diverse team. And I'll get more into my background. So I really started out in construction as an engineer. So rotated through the field. I was a laborer, foreman, equipment operator, welder, surveyor, scheduler, field engineer, and office engineer on a power plant project and then a light rail project in Texas. So over the course of a year, I rotated through those positions. And then they put me in this new role that Kiewit called the solutions manager. And for 3 years, I was responsible for new technology and process improvement, and got to work on everything from nuclear weapon disassembly facilities to natural gas refineries, roads, bridges, tunnels. And then I moved out to San Francisco and worked for a startup company called PlanGrid. So when they came out of Y Combinator, I was one of their first hires. And then I went to work for McCarthy Construction, and McCarthy is another construction firm, but they're the largest healthcare builder in North America. So for 2 years, again, I was dedicated to new technology, process improvement, but now hospitals, laboratories, utility scale solar, much more urban projects. So I was very fortunate to have 5 years dedicated to construction technology, and I was one of the largest buyers at that point in time. So while I was at McCarthy, I founded the Society for Construction Solutions, and this is how I met Darren Bechtel. So over 5 years ago, we created this organization. It started in San Francisco, and it was a way to bring together construction entrepreneurs and construction technologists and construction investors. And I kind of unwittingly organized all of the deal flow that Darren wanted for his new fund. So Darren and I became fast friends. I actually pitched him an idea. I had a startup idea for a software platform, and halfway through my pitch, Darren interrupted me and offered me the job to join him and launch Brick Mortar Ventures. So that's how I got involved. I didn't realize I was being interviewed. Now you can see we're in cities all over the world, and there's no membership dues. If you go to that website, you can see how you can get connected with the chapter leaders over LinkedIn. Great. So I'm going to tell you a little bit more about Brick Mortar Ventures, and then we'll get into trends, and then the really fun stuff, we'll be talking about the emerging technology. So our mission at Brick Mortar Ventures is to be the premier global design, construction, and facility investor, and we really want to be a trusted partner to the industry. So that's why we're here today, and that's why 4 out of the 5 members of our team are former construction engineers. So we really think that understanding the problems that need to be solved is the best way to evaluate technology. So we're really problem-oriented. And then this is where we get our $97.2 million from. These wonderful corporations have trusted us to be stewards of their capital, and the process is we do a capital call, we get the money from these companies, and then we invest it into our portfolio. Yep. And then this is getting into a bit about the strategy of Brick Mortar Ventures. So we call these organizations centers of influence. And I'll just take you through some examples. So you see CSIRO, that is the Commonwealth Scientific and Industrial Research Organization. It's basically the National Research Lab of Australia. And one of their big claims to fame is that's the laboratory that invented Wi-Fi. So it's a really storied and excellent technology research organization. And we developed a relationship with them, and then we understood that their wireless team was really good. We were very interested in how do you get connectivity in a construction project or an underground tunnel, something like that. And then we found out that their Bluetooth team was spinning out a technology, and that's how we found an investment. So another example would be NASA. So we co-hosted for 3 years a robotic and material science construction competition, and we ended up investing in one of the teams that competed in that competition. So this tells you a little bit about our strategy is we can go and develop relationships with organizations that develop sophisticated technology, and then we really bring the understanding about the problems that are needed to be solved and how could that technology fit into the industry. Yep. This is basically what we do day to day. You can see on the left-hand side, you've got all the leads, and we get those leads through our personal network. Our limited partners, those corporations, sometimes sends us potential investments. And then, of course, the centers of influence. It's where we get our leads and our potential investments. So qualifying the lead is a whole process of, seeing if the team is really qualified, is the technology ready, and are they focused on the right problem? And we start adding value very early on. We'll make introductions. We may be involved in the origination of the company. And you see how we revisit. We really don't say no to a potential investment. We tell them actionable information and make introductions, and then we just kind of keep it going, and if they address all of the concerns, then there's a potential we'll invest. But because we're sector specific, we think it's really important to just be generally helpful to construction technology entrepreneurs. Yep, and then you can see if we actually make the investment that comes from our fund. Great. So these are our portfolio companies for the first fund. You can see that we already sold one, Building Connected, sold for $275 million earlier this year. And then our latest investment, Advanced Navigation, on there. So we'll go over a few of these in more detail. Great, so now getting into trends. So this is not just from Brick Mortar Ventures, this is also from my experience working in construction, as well as some lessons learned from our LPs, those big corporations. So what do we think is happening in construction in general? We would say that our core thesis is that construction has been suffering from solution scarcity for a very long time. So we think that there's plenty of smart people in construction, we think there's plenty of economic incentive, and we think that there's lots of problems to solve, but only recently technology has gotten sophisticated enough to solve problems in construction. And one of the reasons behind why it's so difficult is construction is often in a GPS-denied, metallic, dynamic environment. And that's really tough for technology. So think about getting a signal on your cell phone. Think about trying to set up a wireless network. Think about trying just to set up cameras. It's no positioning because no GPS. It's metallic, so it's hard to do a wireless network, and it's dynamic, so I can't even attach a wireless router to a wall because I'm building the wall. So we think that this is an order of magnitude more difficult than manufacturing environments. Yep. So now we would say we're in a time of solution abundance. So this technology is now available. Entrepreneurs are turning it into companies. The customers are getting better and they're investing in innovation. They're separating out of their operating capital actual innovation budgets. That's just never happened before in construction. And we think that's because now the technology is sophisticated enough. Great. So we use this diagram a lot. So really, the idea behind this is that construction is not an industry. Construction is a common process among many industries. So some of the knowledge that we have that we trade on is how different market segments have different contract types. They use different materials. It's in different locations. But there's some commonalities. Yep. So you can see all of the different market segments, and then that dotted line is where we think is the disruption line. So on the left-hand side of that line, the really simple construction, single-family homes, multifamily, retail, we think it's simple enough that a single company could be very disruptive and totally vertically integrated. So one company does the financing, the design, the fabrication, the construction, the facility management. We think it's possible for true disruption to happen on the simple side of construction. But on the more complex side, the jobs are just so risky, so complex that our investments are more a solution that solves a problem across multiple markets. And we think that is very stable because a lot of those markets are inversely correlated. If there's a downturn in tower construction, you'll often see more funding from the government for public transportation. And then when capital is cheap, you see more capital projects, big EPC jobs go. Yep. So this is the way that we kind of look at construction, and what's driving that complexity are all these different complexity drivers. Sometimes you have an architect involved, so you're giving a lot of design freedom, which means there may be substantial design changes later on. In an EPC project, you have a very clear upfront design, but just the sheer logistics and the sheer volume of a large refinery is the big complexity drivers, and they need different solutions. They're motivated to solve different problems. And then from the perspective of a large corporation, trying to adopt technology and drive innovation, this is the way that we've found can be really effective. So let's just say that we are a construction company and we've got 3 major business units: the industrial market, commercial, and infrastructure. So where am I going to focus my time? We think that it's best to focus on where you have the most self-perform and control. So if you don't have a joint venture partner, if it's your equipment, if it's your crews, if it's your fabrication yard, that is a great place to focus your research, and also to tell your IT department that they get their own configuration. I've seen this really hurt the innovation of construction projects when the hospital and the road and the tower all have the exact same information technology configuration. Especially if it's self-perform, your IT department should really do process mapping and analyze how that operation is different from subcontracted construction. Yep. So your business should know which market segment is strategic to the future of the business. I say bring in the scope and just focus on that. And then on the horizontal side, where is a common process across multiple projects where it would really benefit the company to have that wide view? So quality is a great example. If you don't have a software platform for monitoring and analyzing quality across all of your projects, I think you're missing out on a big opportunity. Yep. But finding those areas to focus is absolutely key to making sure you get the return on investment. Great. And then as a corporation, getting involved in working with early stage companies. You always start with getting more value out of the technology you already own, but once that is taken care of, you can start working with new companies, but it's very risky for a large corporation. So this diagram really shows that on the left-hand side, the y-axis, if you're going to put a lot of resources into innovation, then you can do direct investment. I'm going to invest in a very early stage company, or I'm going to work with a research lab and potentially co-develop or spin out technology. That's very resource intensive. But if you're not going to have a lot of resources, investing in a fund like ours, working with a plug and play, there's easier ways to get started. And then on the benefits, you can see that low internal resources with near-term benefits just really doesn't exist. We don't think that. And our relationship with those corporations is about 7 years, is a 7-year fund life, is the duration of our relationship with them. And then in the top right, you can see how it's really important to have the customer feedback loop. If we were to say, what are we looking for an investment, we're looking at a company that has a demonstrated customer feedback loop. So they make a product, they put it in the hands of their customers, and then they make changes, thoughtful changes based upon customer requests. Great, so now the really fun stuff. So we were talking about centers of influence, and a really interesting center of influence is an organization called Shell TechWorks. And Shell TechWorks is the R&D laboratory for Shell Oil and Gas. So where did Shell TechWorks come from? Well, when Deepwater Horizon happened, that horrible oil spill, Shell said, wow, that could have been us. And they went to Draper Labs. Draper Labs is a laboratory at MIT that received the first contract for the mission to the moon. They did the guidance technology. And now Draper Labs does about $500 million in revenue every year doing research for the US military as well as large corporations with really tough problems. So Shell gave Draper Labs a bunch of money. It was very successful. That spun out and became Shell TechWorks. So basically, aerospace engineers working on oil and gas. We identified that as an important center of influence, developed a relationship, and then we were asked to spin out a technology they developed called Cumulus. So what does Cumulus do? Cumulus eliminates leaks on natural gas or any type of oil and gas refinery. So what they're doing is they're using these Bluetooth-enabled torque wrenches to capture the torque values of any bolted assembly. So if you've got a high pressure, high temperature bolted assembly, you can use their platform as well as these new Bluetooth-enabled torque wrenches to make sure that you're hitting the proper torque value and that you're following the proper torque pattern. Now that's huge for the environmental impact, safety, quality, production. It's a very big deal, and this is a great story of us partnering with an organization, and then we worked with Shell Ventures on the spin out, and I've got the board seat, and they're doing exceptionally well. And they'll be expanding, and something to keep in mind is that that logo may change. Their focus may even change. So these companies are on a trajectory. They're starting with smart tools and Bluetooth-enabled torque wrenches and oil and gas, but there's a lot of tools out there, there's a lot of market segments. So they'll be moving into energy, and they'll be broadening the platform where you don't have to use the smart tool to use their system. It could just be a proof of presence of a competent person to inspect it. So you can think of it as like a systems engineer's approach to quality management, especially mission critical quality management. So this next one is called HoloBuilder. And HoloBuilder is a really interesting company and really came up with this idea back when I was at McCarthy Construction. And they leveraged this new device that first came out of Ricoh. So this is a spherical camera. So if you've ever used Google Street View, this is a camera that takes an instantaneous perfect photosphere, and then what you're seeing is a platform for these photospheres, and the user is turning on the computer vision algorithms to go and look for material. So what you'll see right here is each one of those horizontal lines is a location over time, and those white dots are computer vision results. So you'll see right here that it's highlighted the drywall construction. So we have an objective result showing when the construction started. So if you're doing payment applications, you're managing project controls, this is a way to organize all of your imagery for your construction project, and then run a computer vision query into the data set and update your project schedule. So if I'm trying to submit a payment application to the client, I've got proof and a very detailed report of how much work has been performed over time, and you can see they have multiple algorithms. So here's another one for HVAC. And we would call this technology in the category of tagless asset tracking. You may be familiar with RFID, barcodes. Well, it's really not logistically feasible to tag every asset on a job site. So using computer vision is a much more efficient use of time. Yep. So that's HoloBuilder. Now, this is NoMeah, and this is the company we spun out of CSIRO. So this is a really interesting technology. If you're familiar with Bluetooth, this is Bluetooth Low Energy Asset Tracking. They call it BLEAT. And what you see there are 3 different devices. The top one that I'm holding is one of the beacons that you stick to the wall, and then those 2 on the bottom are 2 different tags. So right now the product is focused on material management. So you would put those beacons in your factory. So for this example, they're doing a building facade. And you'd put the beacons in the factory, you'd put the beacons at your laydown yard, and you'd put the beacons in your staging area. So think like the landing for a elevator. And then those tags, of course, are on the materials, and then you're able to maintain min-max inventory management. So if I've got 3 crews that can put 5 panels in a day, I need to make sure I have 15 panels on site, or else we're not going to have enough material for production. So that is a fundamental part of production efficiency in Toyota manufacturing methods, all that stuff. So min-max inventory was the first application of this wireless technology, but it'll be expanding out of that. Remember, they're on a trajectory, and they're just starting with this because this is where urban towers need this solution and data centers need this solution. But the technology will get better over time, and they're going to expand the scope and track assets and tools and people and stuff like that. Now, here's an interesting investment of ours that is really not a smart technology. It's really just a device you put on your hard hat, and it's got a lamp on the front and a ring of LEDs around the hard hat. So it's really useful in dark environments where you need to illuminate your work, or if you're working close to a highway, or you just need to improve your visibility. But this new device that they're releasing will have a little panel on the front you can remove and add additional sensors. We actually want to experiment with a couple different sensors. One of them will be a electromagnetic field detector. So think about if you open up an electrical box and it's charged, we could have your hard hat alert you to the safety concern. Also, we can add what's called an IMU and track your position indoors for time studies. So it's called Inertial Measurement Unit. Now here's another one. Now we're getting into the more extreme technology. And this is something that's actually in stealth, so this is a treat to share with y'all. It's called Canvas. And the technology originated from DARPA, US military research. And what they were trying to solve was how do you apply stealth coatings to aircraft? It's very nasty chemicals. It's a really poor ergonomic process. And they put a lot of money in trying to figure out how to use robots to do the surface finishing for aircraft. Well, didn't really take off, but the technology ended up as a drywall finishing robot. So Canvas is a drywall interior walls subcontractor. They don't sell this machine. They are actually a contractor that uses robots to do painting and surface finishing. And it can take a 9-day process and cut it down to 2. So instead of putting on a little bit of material and sanding and repeating that process numerous times over multiple days, this is so precise, it can place the material on the wall, a very large coating, and then sand it perfectly to level 5 finish. And what their vision is they want to bring automotive quality paint to interior walls. So they want to do better than a human can. That's really what their vision is. They want the interior walls for really high-end buildings to be like automotive quality. So this is a really difficult technology. The leadership team is a lot of people from Boston Dynamics and MIT Robotics, and it's very difficult to bring the robot to the task. So we're getting into the differences between manufacturing and construction. So if I'm in a work bay on a manufacturing line, my task is coming to me, and my tool is right here, and my material is right here. That's really useful when trying to get productivity gains. But in construction, you've got to go where the work is. So the work face is moving, and sometimes I need to go to a different location. So getting a robot that can do that is very difficult. And then the robot is so disruptive to the process of interior wall construction that it didn't make sense for them to sell the robot, because their customers would have to change their crew composition. They'd have to change the materials they use. It's truly disruptive. So they've got this new business model. And if you remember back to that chart, this would be one of those vertically integrated companies where they have to have their own materials and equipment and all of that. But they work really well with laborers, because the laborers are much more interested in learning how to use new technology. This is almost like running a CNC machine, but on a job site. So Connect Homes. So this is, in my opinion, the most efficient construction company in the world. It's one of our investments, and what they do is, it's not the first company to do modular construction, but we think they're doing it in a really special way. So if you go onto the Connect Homes website, it's like buying a car. You know the price up front, and you get to make a few changes to the design, but you really don't have a lot of design freedom. Like with a car, you can't change the axle size or you get the concept. But the modules are all compatible with the intermodal shipping network, so you have efficient logistics. So I don't have a lot of design complexity. I have really efficient logistics and shipping, and then the production is a real production line. The VP of operations is actually a former Toyota and Airbus, and has set up a true manufacturing, and they're able to produce a home in 4 days. Now, it depends upon the weather if they can install it, but there is substantial completion done in a controlled environment with this level of complexity to their material management. So NoMeah is trying to help you to organize your material flow. This is the level of complexity for Connect Homes material flow, and really shows how that has to be. The system is totally built around the flow of materials. So this is a great visual to kind of appreciate how important material management is to construction. And then I've got a treat for you. This is a clone. And clone is used by Connect Homes in their factory. So if you're familiar with the Hololens, that's the augmented reality headset. And if you're familiar with virtual reality, what you're seeing here is two people in two different locations collaborating at a Connect Homes production bay doing the waterproofing for the window. So there's one person wearing the HoloLens, and they're really there, and then that device is capturing all around them. And then the person at the other office is in virtual reality, and that's that person right there, and they're having a conversation about where should you be putting the waterproofing and what does this process look like. So this company is based in LA, and you can imagine how much time is spent with being able to do telepresence and virtually resolve an issue rather than driving through LA traffic. And they're even using the wall there as a whiteboard and an opportunity to instruct. So we see this as the future of augmented reality rather than some assembly diagram. That takes a lot of time to populate. This is more of that ad hoc support. This is another portfolio company of ours. These are the team that won the NASA competition. So NASA worked with us to produce a competition to understand how do you print structures on the moon and Mars. And this team was able to win the structural competition, and they make the largest 3D printed objects in the world. And these companies are on a trajectory, and what they make now is 3D printed building facades. So they have a factory that 3D prints whatever design you want. Right now they have a few designs to choose from, but these building facades, the rain screens, are half the cost of the custom-made solutions that you typically see. So this market segment is a perfect fit for 3D printing, and it's not 3D printing on site. It's in a controlled factory, and everything goes through quality control before it's sent to the site. We actually don't think it makes much sense to 3D print on a job site. Great, I'm right on time. So thank you all very much, and I'll be around and happy to answer any questions. Thank you.
Thank you very much, and big round of applause to Mr. Curtis Rodgers.